So when we talked about this before, okay, where you had a central angle, all right, and a central angle, the vertex of the angle is on the center of the circle itself, all right. An inscribed angle meant that the vertex of the angle itself was on the circle, okay, and you have this intercepted arc here for the inscribed angle, and for the central angle, of course, you have this as your intercepted arc, all right. So it meant that if this was 65 degrees, then the intercepted arc was also 65 degrees. Whereas if we come down to the inscribed angle, if this was 60 degrees, then this would be 120 degrees. That's interesting. I should put angle here. Okay, inscribed angle. All right. So the arc was twice the angle, or the angle was half of the arc. Okay. And that's pretty much all it is. You start to have it look a little bit more complicated, but it still seems to be fairly familiar, because if this arc right here has this angle for its intercept, what's the measure of this angle? 43. What's the measure of this arc? 104. Okay, that's all there is to this. Of course, it gets a little bit more complicated, but not much. All right. Um, Braden, what's the measure of BC? Yes. Arc BC. 96. Very good. You understand how it's 96? Okay. Because again, this is the angle, this is its arc. The arc is twice the angle. So 48 times 2 is 96. Let's do this one. What's the measure of angle C? I was talking to you anyways, but thank you for raising your hand. Very good. Okay. All right. So if you have two angles, these two angles share the same arc, okay, then the angles are equal, okay? If they have the same arc, the angles are equal. So you introduce a little bit of algebra to this, because if I look at these two angles right here, all right, these two angles have this as the intercepted arc. So that means these two angles will be congruent. So if I'm looking for angle R, I would set up 12x minus 13 and set it equal to 9x plus 2. I'd solve for x and plug it back in. Okay? Questions about this? Okay, good. All right. This is the only thing that makes this a little bit complicated. Okay? And please pay attention to this. If I have an inscribed angle, and this inscribed angle intercepts the diameter of a circle, this will be a right angle, which makes this a right triangle, which gives me license to do other things as well, like Pythagorean theorem and special right triangles. Okay? So, pay attention to that. If this angle intercepts the diameter, it's a right triangle. Now, notice here, I have this angle right here that intercepts this diameter. How would I solve for x for this? we would add up all of these angles and set it equal to 180. Or you could see that, well, if this is 90, then this angle plus this angle has to also equal 90. So I would take x plus 4 plus 8x minus 4 and set it equal to 90. All right, solve it. Solve for x, plug it back in. Remember the distinction here for a second. This did not say find x. This said find angle B. So I would have to solve for x and then plug it in right here to find out what angle B is. Do you have a question? No. Okay, I just saw the hand. All right. Inscribed. Remember what inscribed meant. Inscribed meant, I can't probably do this with this tablet. Inscribed meant that the angle itself is on the circle. Okay? So if I have a quadrilateral, which is 4 sides, an inscribed quadrilateral means that the vertices are on the circle itself. Okay? Now, if you have an inscribed quadrilateral, the opposite angles are supplementary. What does supplementary mean again? If you add up 2 angles together, they equal what? 180. Okay? So K plus M is 180, and L plus N is 180. So if I'm solving for x here, I know that R is opposite of Z. So I would take 4x plus 2x plus 30 and set it equal to 180 and solve for x. Questions about this? 3 questions. You cannot. And the only reason, it's not saying that you couldn't do it, but I don't know anything about angle T. So I couldn't put that in there. Okay? All right.